Alright, ladies and gentlemen, we are solving some right triangles today. So what we're going to do is we're going to actually start applying a lot of the things that we've learned in the last unit and this chapter as well, and apply that to different word problems and triangles, etc. So basically, when you're asked to solve a right triangle, what you're trying to do is you're trying to find all the missing parts and pieces. So here, if we look at this example, it says solve for all the missing information, round answers to the nearest hundredth. If it's telling us to round to the nearest hundredth, what that means is we're going to want a decimal as an answer. So sometimes if it says you want an exact value, that means radicals, fractions, etc. If it says the nearest hundredth or an approximate value, that means you're finding a decimal. So to start off with, what we want to do is we want to identify what we have and then what types of trig functions we could use to find what we're missing. So what we have this 9.3, and we have at 49 degrees. One of the easiest things to find, probably right off the bat, is beta, because we know this is a right angle, so it's 90 degrees. We know this is 49. And so if we subtract both of those from 180, we should find beta, which down there I'll show you is 41 degrees. Next up, we want to find a side length. So we still have these two parts. Let's say we want to find side length B first here. So to do that, what I'm looking for is from this angle measure, I have an opposite side and I have an adjacent side. So what trig function would use opposite and adjacent sides? Hopefully we remember that would be a tangent. So we're going to set up tangent 49 equals B over 9.3. So then to solve this problem, we would multiply both sides by 9.3. And plug that into our calculator, and you would find that B should come out to equal 10.7. Or roughly 10.7. So lastly, then we want to find side length C. One thing I would not recommend doing, don't just do the Pythagorean theorem to find C, because the problem with that is if I had found B wrong, and I plugged B into the Pythagorean theorem with a 9.3, I've automatically got C wrong. So instead, if I work it out separately, just like we did with B, even if I maybe made a mistake on this one here, there's still a good possibility that I would get C right, and so I wouldn't lose all credit. At least I'm getting, part of the problem correct. So now, if I'm looking at C, what trig function would use an adjacent side, a hypotenuse? So in this case, we have a cosine. So we're going to take the cosine of 49 degrees and set it equal to 9.3 over C. So one way to get C out of the bottom of the fraction here, you would multiply C by both sides. So I multiply both sides by C, those go away, and so I'm left with a C and then a cosine of 49 equals 9.3. Now how would you think I would get the C by itself? So at this point, divide everything by the cosine of 49. C would equal 9.3. It's a terrible looking 3. There we go. Over the cosine of 49. And we should get C to equal 14.18. So that's really all you're doing here. Is the keys is just identifying what you know, and then relate those to the different trig functions to find what you're trying to solve. We look at the next one here. A very similar type problem again. So I would have you guys try this on your own and see if you can get it right. Oh, this one. How do you think we would do this? And we don't even know an angle measure, which is kind of a trouble. We know two side lengths. Now, to start with, the easy way to go first is, in this instance, we know those two for sure. Now we can use the Pythagorean theorem to find b, side length b, because we know those are right because we're given. So we set up, 15 squared equals 7 squared plus b squared, and we solve, and hopefully we get 13.27. So now let's say we want to solve for beta. So the 7 from beta, 7 is an adjacent side, 15 is a hypotenuse. So what trig function would incorporate an adjacent and a hypotenuse? That should be a cosine. So we're going to have cosine of beta equals 7 over 15. Now how you get the beta by itself? You are going to take the inverse cosine. As if we remember back from Algebra 2, inverse functions cancel normal functions. So take the cosine inverse of both sides. Basically, it's like canceling out the cosine there. And beta would equal cosine inverse of 7 over 15, which we should find to be 62.18. And then theta would be 27.82. And once again, you can do the inverse to try to find theta as well. In this case, I skipped to just try to keep the video a little bit shorter. But hopefully that makes sense. Here's the homework assignment if you'd like to take a look at it and get a head start on it. Otherwise, that's it for today's lesson. I hope it makes sense, and I'll see you guys in the morning.